Hey guys, so in the last lecture we have seen various router system, that is single router system, two router system, three router system, geared router system, and also routers having shaft with different diameters. So today we are going to see one of these examples of a two router system having different diameters and how we can convert it into an equivalent diameter shaft of having any one of the that any one diameter. So let's read the question. What is said in the question? So two rotors A and B are attached to the end of a shaft of 50 centimeter long. So these are two rotors. This is A and this is B. Now distance between this A and B is 50 centimeter. Distance between A and B is 50 centimeter. So weight of rotor A is 300 Newton and its radius of gyration is 30 centimeter. So weight is given as 300 Newton and radius of gyration K is given 30 centimeter. Now and corresponding values for B. So for B is given weight as equal to 500 Newton and radius of gyration K is 45 centimeter respectively. So the shaft is 7 centimeter diameter for the first 25 centimeter. So suppose this is the 25 centimeter. So first 25 centimeter it is 7 meter, 7 centimeter. So up to first 25 centimeter, the diameter of the shaft is 7 centimeter. After that, for the 12 centimeter for the next 10 centimeter. So for the next 10 centimeter, so let me take this as 10 centimeter. It is 12 centimeter. So the diameter of the shaft is 12 centimeter. Then 12 centimeter for the next 10 centimeter and 10 centimeter for the remaining of its length, and the remaining length, the diameter is 10 centimeter. So what is the length remaining? So there is 50 minus 25, so 25 is remaining minus 10, so 15 centimeter is remaining. So it is 15 centimeter. So the modulus of rigidity of the shaft material, so G is given, that is 8 into 10 raised to 11 Newton per meter square. So what is our goal? So first is to find the position of the node, and second is the frequency of the torsional vibration. So two things has been asked. First, node position, and the second is frequency of the torsional vibration. So if I have to find the node position, so we can only find if the diameter is we have only formula if the diameter is same throughout. So we will convert the system into a single diameter system of 25 centimeter. So if we are converting it, then the length will change. So what will be the length, and diameter we are fixing as at 25. So the formula for the length is L is equal to L1 plus L2 plus into D1 upon D2 raised to 4 plus L3 into D1 upon D3 raised to 4. So there are only three lengths, 1 2 3, so this will work. So the first length is 25 centimeter, we will convert this into meter, so SI unit, so 0.25 plus 0.1 into d1 upon d2, so that is 7 divided by 12, so we are converting into centimeter, but it's ratio, so it doesn't matter for ratio. So 7 divided by 12, so raised to 4, plus L3, it is 0.15, so that is 7 divided by 10 raised to 4, so this will come out near to 0.2975 meter, so which is equal to 29.75 centimeter. This is the length. This is the length of the equivalent shaft. So now, as we have got the length, we are now interested in finding the node. So as we have converted it into a single length, so we have to find the node. So how we can find the node? So if this is a two rotor system having a single shaft diameter of 7 centimeter and length is 29.75 centimeter, rotor A and rotor B. So now, as there will be vibration, so the node will generate, and we have to find this the node distance from left hand side. Suppose, so we know that that is IA into LA is equal to IB into LB. So we know this formula because as they are both the rotors are on the same shaft, so their natural frequencies will also be the same. So therefore, so if we can find any of the length, we are interested in finding the length. So distance LA and LB are the distance from the node. So but before that we need IA and IB. So how we can find IA and IB? IA and IB are moment of inertia. So as moment of inertia is given, so no, moment of inertia is not given. So instead of that, weight and radius of gyration is given. So as we know that that I, moment of inertia, is mk square. So we will use this formula to find IA and IB. So but weight is given, so as we know weight is mg, so we need to divide, so m will be w by g, it will be equal to m. So IA will be w by g k square. So what is w for A? So let's see. So that is 300 Newton and k is 30 centimeter. So it is 300 Newton into 30 centimeters, so 0.3 meter square divided by 9.81. As we know that G is 9.81. So this IA we will get 2.7523 kg meter square. Now IB, so IB similar formula. So that is, what is the value of IB? So weight is 545 centimeter. So it will be 500 into 0.45 whole square divided by 9.81. So IB we will get it as 10.3211 kg meter square. So IA and IB we have got. So we can use IA and IB. Now the bigger question is LA, how to find LA or LB. So we don't know both the values LA and LB, but we know the total length. So if I will just replace one of the values with L minus LA, then we can find the value of LA. So we can have it like IA LA is equal to IB LB, but as we know that L minus LA will be IA, because LA plus LB is equal to total length. We know the total length, but we don't know this LA and LB. So we will use this formula. Uh, so I will just take the ratios of IA divided by IB is equal to L minus LA divided by LA. So IA divided by IB is equal to L divided by LA minus 1. So I will take minus 1 on the left hand side. So IA divided by IB plus 1 is equal to L divided by LA. So if we move forward, so we'll get that we are interested in finding LA, not L. So what is IA? So IA is 2.7523 divided by 10.3211 plus 1, which is equal to L divided by LA. But what is L? We know the value of L. So the value of L is 0.5. As you know, the value of L is 50 centimeter total length. That is 0.5 divided by LA. So the value of LA will be equal to 3. So the value of LA will be equal to, uh, 23.48 centimeter, and similarly LB will be equal to 6.26 centimeter. Here the total length is not 0.5 but the equivalent length, which we have found out recently. So the equivalent length is 29.75 centimeter. So this we will use as equivalent length. So that will be equal to 0.2975, and the LA and LB will be this. So total length L will be equal to 29.75, nearly 6 plus 3 9, and similarly centimeter. So we have found the distance of the node from the left and from the right. So that is LA and LB. Now the second question which we are interested in finding is what is the natural frequency of the system. So how we can get the natural frequency of the system? So as we know that T by theta is equal to Gj by IL, and as we know that omega n is equal to under root T by theta, or sorry, that T by theta is equal to Gj by L, and that is uh, tor- stiffness, that is torsional stiffness. Now omega n, as we know that it is K by M, or in rotational Kt by I. So this Kt we will use, so omega n will be equal to under root Gj by IL. So if I want to find the natural frequency, this is the formula Gj by IL. Now which I or which L? So as we know that IA LA is equal to IB LB. So any of we can take, because the multiplication of both the rotors of I and L are same. So you can take IA or LA, IALA or IBLB. They are one and the same. Now what is G? So that is modulus of rigidity, that the value is given, that is 8 into 10 raised to 11 Newton per meter square. Okay, fine. So now what is J? So J is polar moment of inertia, and whose value is pi by 32 d raised to 4. What is d? D is the diameter of the shaft. So what is the diameter of the shaft? So the diameter of the shaft is 7 centimeters, so it is 0.07 raised to 4. So which is nearly equal to 2.357 into 10 raised to minus 6 meter raised to 4. So that is J. So we have got G, we have got J. you got I and you got L, so we can find omega n. So that is equal to 8 into 10 raised to 11 into 2.357 into 10 raised to minus 6 divided by 0.2348 into 2.7523. So which will be equal to omega n is equal to 271.87 hertz. Sorry, not hertz. So omega n will be equal to, sorry, I just said 2 into 2.7523. So this is the value of omega n. But here we have to find the frequency. So omega n, as we know, is it is twice pi f. So if I want to find f, so f will be equal to omega n by twice pi. So the f will be equal to this value. So f will be equal to this value divided by 1 upon 2 pi. So the value of f will be 271.87 hertz. So this is the value of the frequency, 271.87 hertz. This is the frequency of torsional vibration. So I will just repeat the process. So what we have done here. So here the question was that two rotors having different diameters. So they are having different diameters and we have to find the position of the node and the frequency of torsional vibration. So to find that, first we have converted this whole system into an equivalent system having single diameter. And what the diameter is, the first, whatever the first length, whatever the first shaft diameter is, that we will take. So that we have taken 7 centimeter and we have found the length using the formula. So that is 29.75 centimeter. Now if I want to find the node, so that will be IALA is equal to IBLB. So I is equal to mk square, as we know that we can find with this formula the value of moment of inertia I. But do we have m? No. Do we have k? Yes. So how we can find m? So what else we have? So we have weight. So with the help of weight we can find, because weight is mg. So that will be the formula will be of moment of inertia w by g into k square by substituting the value of mass. So we have found the moment of inertias IA and IB. Then we have put in this formula, but here we don't know LA and LB, but we know the total length, that is L. So with the help of this formula we will find the value of LA and LB, but here total length we have to use as equivalent length and not the 50 centimeter value. So I'll get the value of LA and LB. Now we have to find omega n of the system. So what will be the value of omega n? So omega n value will be under root kt by I. So that is gj by il. So we have g, yes. We have ia, la, yes. We can use ILA or IBLB. Both are the same in multiplication. So do we have j? No. So how we can find j? So j we can find by this formula, pi by 32 d raised to 4. The diameter we have taken as equivalent diameter is 0.07 meter, that is 7 centimeter. So with this help the frequency will be 271.87 hertz. So we have fulfilled our objective, that is to find frequency, and our objective was to find the lengths of the nodes, that is LA and LB. So this concludes this whole numerical, and similar type of numericals can be asked in exam and have been asked in the exams previously with fewer modifications. So this was the numerical for the torsional vibration. So I hope you understood each and everything, and this concludes our chapter, that is free vibration, free and undamped vibrations. So I hope you understood each and every part, and from the next lecture we'll start the forced vibration and isolation and transmissibility. So hope to see you in the next lecture, and thank you very much.